We zijn weer toegekomen aan de laatste spreker van vandaag. En dat is André Banken. En André zal het in het Engels doen. Of in het Duits, dat kan natuurlijk ook. En het is van 2G. Maar ik weet niet, André, of ik het goed uitspreek.
2G Energy.
2G Energy.
In English, yeah.
Ga je gang.
Thanks. As a German company, thanks for having us join today. We just joined officially the H2 platform yesterday. So we're the newest member. And, well, thank you very much for having us here. I think a lot of the items I have in the presentation were already mentioned today. Oh, sorry. Were already mentioned today by many of the speakers from the EU, from Hydrogen Europe, and by just the previous gentleman as well. So some of that you might have heard already, so I'll try to stick to the core pieces. Before that, maybe who is 2G? 2G is a German-based company founded in 1995 for cogeneration systems. So the combined utilization of heat and power for gasified fuels. Why are we here today? Well, our core range of products goes for biogas and natural gas applications, actually in the range of 20 to 4,000 kilowatt. But since quite some time, we also have gas engine-based cogeneration systems available for 100% hydrogen applications from 115 kilowatt to 750 kilowatt of electrical capacity. So on the map that you can see on the presentation, you see we're just across the Dutch-German border, close to Enschede. So close enough for being part of this. 2G itself, we have nowadays 700 employees. We're stock listed in Frankfurt in Germany since 2007. And these days we have roughly 7,000 installed cogeneration systems altogether in more than 50 countries. On hydrogen base, not that much right now, but we'll show you some examples on the slides later on. So maybe this is the final slide about 2G, and then we come to the application. 2G has established itself as, again, solution provider for cogen systems in this power range 20 to 4,000 by our own R&D and development works, especially in gasified application, which brought us to the entire hydrogen solution. But of course, we're also quite strongly emphasized on the service and after sales, as well as in project development and implementation, which you will see on the next slides is quite an important piece of the puzzle if we look to the, how did the EU lady call it, on the demand side of the hydrogen. So you can see here, where are we represented at the moment? You see in Europe, that's quite a bit. So rest assured that there is enough references to look at some stage. And for people not aware what a cogeneration system, or in Dutch is warmtekrachtkoppeling, I believe, what a cogeneration system does. I mean, we take the gasified fuel gas, and again, this can be natural gas or biogas or hydrogen, or even a blend, a mix of those, as also was mentioned in the presentation of Hydrogen Europe earlier, and convert that at an extreme high efficiency rate, also around 85% total efficiency, to electricity, either for direct supply or for an end user, or for supply to the electricity grid, and on the thermal side, provided as, well, hot water, for instance, or steam if we're talking for an industrial or commercial application, or even as chilled water if we talk about district cooling, for instance. Where is this usually applied? Well, everywhere where there is a demand for electricity and heat at the same time. So looking at it from the right hand to the left hand side, that's of course the classical waste to energy sector that was already mentioned in the previous presentation a little bit, on landfill sites at wastewater treatment facilities, but of course in the industry, in heating grids, in the food and beverage industry, in swimming pools, and as well to the public and residential sector. So everywhere where this demand is given, you can apply it as well. So how does the entire process look if we look at hydrogen? There was quite a bit of discussion and a lot of information today already about offshore wind power plants, about solar, about overseas imports, so you know all of that already. There's discussions about electrolyzers, so you know that as well already. And even earlier this week, there was the green light for GasUnie here in the Netherlands to even use the gas infrastructure for transport of hydrogen. So I'll just stick to the utilization side now. And with that, and looking at gas engine technology for hydrogen, we basically have two approaches. One approach is, once the hydrogen is available, either use it directly as pure hydrogen at site, produced at site, or received via the existing gas infrastructure, where we either use it as 100% hydrogen, or without a change of technology, use a blend of it, of 20% hydrogen, 80% natural gas, 50-50, 70-30, whatever is available. The engine technology is quite flexible there. And of course, if you look at the bottom part of the slide, also the CH4 or biogas provided by biogas facilities injected into a natural gas grid, so biomethane, can be utilized in that sense as well, which makes it quite a versatile technology in that sense. So how does that work on an engine? And we heard it already in the previous presentation for turbines. What you see on the upper part of the slide now is how the typical natural gas cogeneration system actually works when we come to the utilization of the fuel. So we have natural gas and air that is mixed into an external gas mixer, turbocharged, cooled, and then utilized in the engine to produce the aforementioned power and heat. On the hydrogen utilization, it's quite a similar process, with the major difference being that only the air is turbocharged and cooled externally, while the hydrogen is directly injected into the combustion chamber, so we do not have this, well, premature ignition that we try to avoid at all costs. I mean, it's a bit more technical than that, but this is what it really sums up to: the switch from external air-fuel mixture creation to an internal one. This is how it looks like on a gas engine application. So we switch an external gas mixer to a port injection system. And here comes the special trait about that. That means even existing cogen system, existing gas engine applications, so infrastructure that is installed today or that has been installed already, can be made, can be retrofitted, that hydrogen can be utilized either as a 100% fuel or even as a blend. That means even the infrastructure, not only the gas infrastructure, but also the power and heat infrastructure that is existing today and is implemented in the next couple of years, as the hydrogen becomes gradually more available in quantity and lower in price, the transition can take place without new infrastructure investment everywhere, which is a big cost saver, we believe, on all sorts of customers as this transition happens, because it will not be a flipping of a switch. As we believe, we all agree, it is an ongoing process that, well, will take the next decade or even more in executing that. From a bit of a practical implementation point of view, this is how we imagine this to happen in the future, for example, in the Netherlands. So we take the existing cogen system, for example, for a city block heating or a city block power supply that is now today still based on natural gas or biomethane power generation, and supplies electricity and heat to the residential sector. This can be private houses, that can be apartment buildings, it can be schools, hospitals, whatever is connected to that district heating grid. And of course, electricity will come from renewables directly when they are available. As we know, wind and solar have their volatile shortcomings where a storage technology is needed. And the gentleman from Hydrogen Europe was quite strong in his stance that battery might not be the long-term solution for that, and we certainly agree on this. So once hydrogen becomes available in larger quantities by whatever source, direct generation via hydrolysis, electrolyzer, sorry, or overseas imports, the yellow pipe, so the methane gas, changes to H2 at some point. It can be as a blend or as a full hydrogen changeover, and still we have the same infrastructure, and we still can reliably supply electricity and thermal energy in whatever form to the local residential districts, companies, whoever is connected to it, and have by that the transition from fossil fuel to renewable-based fuel for the safe supply of energy and power on demand. That means we do not have to rely on the fluctuations that wind and solar naturally have, but can use the power when it is actually needed, which can even incorporate, with this new two nice cars here, the mobility sector. So either as power for the electric cars when it is needed, or you take it from the hydrogen grid and fuel them directly as electric fuel cell cars. So the versatility is definitely there and a given with these, with cogeneration systems, with gas engines being a part of it. And of course, last but not least, it also helps manage demand and supply, because again, gas engine systems are flexible on shifting loads. They can do island mode operation. That means they can even provide off-grid energy supply in case of a blackout. And last but not least, they help support the stability of the overall electricity grid, which is some of the more technical advantages on that side. And if we look at that, how to come to carbon-free heat and power supply in a living district, for example. As always, it's a concert of technologies. Yeah? Thermal insulation on the buildings itself, city block heating via centralized cogeneration systems, first on methane, then on a blend maybe, then on hydrogen, via renewable energy supply, and of course, along the entire way, without the emphasis again on having to invest too heavily on completely new infrastructure, as GasUni is going to do, as we are doing right now, as my previous speaker has already mentioned it. So you see this entire story. It's not just us, it's a lot of people following the same line of thought, and I'm happy that they're following the same line of thought. That means we're all more or less on track. We have quite a few references to show. If people are interested, please contact us and we can share further details with you. And with that, we're open to discuss possibilities and ideas. Please don't hesitate to contact us. Thank you very much for your patience.